center. Today I have five topics to share. The first one is the introduction, the wide field expansion to issue, goals, and the challenge. And second one is how to using the one-step tuning scheme to separation of grand users. And third is how to using the inline debate organizer to separation of grand users. The first is how to using the active selection with the one-step tuning scheme and the inline debate organizer to separation of grand users. And then in summary. The first we will see the issue in general, wide field expansion, and high force rate on breaking point and relay. Where the expansion hard to fine-tune the feasible recipe, and it needs long time to fine-tune the recipe due to many process parameters needed to optimize. And there we will see the 4 goals for wide field expansion. On the new function, sensitivity tuner. Sensitivity tuner can set the recipe set up time. And we can use the debate binning system to filter the nuisance. And we can use the active selector choosing the feasible light source. And we can use the high sensitivity light source. And we can use these 4 goals on the wide field expansion and set the good expansion recipe. And next we will see the challenge for grand separation in wide field expansion. We can use the filter system to filter the nuisance, but we will lose the DOI. And from this example, we can see a nuisance and DOI have the same patch image, and it is not easy to filter on the inline debate organizer. And when nuisance and DOI have the same grayscale, we cannot easily to filter the nuisance on the one-step tuning system. And it is hard to distinguish the DOI by one light source. So, on this advanced wide field expansion tool, we still have the grand nuisance issue. And now we will see the example for trial between the different sensitivity on wide field expansion. On the left side is the high sensitivity expansion. We gather the worst nuisance and the less DOI. And right side is the low sensitivity. Is the separation of major nuisance and only got a big size DOI. And if we use this recipe to expansion, we will lose the important DOI. So now we will introduce the one-step tuning function. The one-step tuning function is using the one-time hard scan and to get the hard defense grayscale. And using the debate grayscale to plot the grayscale distribution chart. And we will set a segments ratio bar to filter the nuisance on here. And for this 2 example, if we choose the mode 2, we will gather more DOI. And on here, even if we set the segment ratio bar on this example, on here we can see the grayscale have the nuisance and the DOI. And we see we cannot distinguish from DOI and the grand with the one-step tuning scheme. And on here we will gather the nuisance ratio is close to 46%. And now we will see the inline debate organizer function. The inline debate organizer function is the like here. Is the inline debate organizer tree. It filter the nuisance depend on the debate feature. And depend on this feature, this rule, we will filter in the nuisance. And from the graph and the micro-bridge comparison for the patch image, it demonstrates that the DOI and nuisance cannot distinguish easily by using inline debate organizer function. And due to these 2 types patch image with similar grayscale and size. And next we will see the example. From these 2 examples, we can see the nuisance and the DOI, they are already the same patch image. So we will hard to filter the nuisance by inline defect overnight. And now we can see the feasible light source by active selection. The selection of optimal light source is using the active selection feature in its spectrum. The best inspection mode could be determined based on the defect signal to noise ratio. And we have the 55 light source and on the active selection function on this table. And this rule is on the nuisance type. We will choose the low signal to noise ratio. And on the DOI table, we will choose the high signal to noise. And on this example, we can see the 4 light sources on the ground picture. And we can see the DUV broadband and the deep band is ground separation better than UV G9 and the I9. And if we choose the DUV broadband and the deep band, we can get the best mode. Now, the inspection result after the recipe optimized. The left side is low sensitivity inspection, and the right side is optimized recipe. After we selection the feasible light source and setting with optimized ratio, and with the inline defect overnight function, and metal ground wall separation, and more DOI will found after metal ground separation, and there are additional 2 types, less gum and collapse. And the defect collateral after recipe optimization. The bar without the slash is the low sensitivity review result. And the bar with the slash is optimized review result. And we can see here, with the force and the scan and collapse, the nuisance is separation from 80% to 15% in average. And here we can see the scan and collapse is the new unique defect from the optimization recipe. And the summary, and on this advanced wide field inspection, we can get the better WPH and less setup time, but we still have a real challenge in metal ground. And from the metal ground separation, we can use in the feasible active selection function and the one-time step tuning, and using the inline defect overnight function to separation the metal ground. And if we after the recipe optimization, we can get the unique defect like the scum or the collapse defect. And we can implement this methodology on the back-end copper process and front-end polysilicon. And it's the same, we can implement the same methodology to separation the nuisance of ground. This is my conclusion. Thanks for your attention.
Any questions? Really? No? It means you did a very good job. Thank you.